So this morning I thought I would work a problem for you. This one is the basis for how a mass spectrometer works. Basically, you shoot a charged particle into a uniform magnetic field so that it begins to go in a circle. Why is this? Well, if you imagine a magnetic field, let's say in this case coming out of the magnetic field's coming out of the page. When you shoot the charged particle into it, the velocity cross with the magnetic field causes it to move in a direction perpendicular to the velocity. All right? So in this case, V crossed with B would be a vertical force. And this force is always perpendicular to the direction of motion. So this gives us a uniform circular motion. So let's look at the problem we have here. A proton moves 7.5 times 10 to the 7th meters per second perpendicular to a magnetic field. The field causes the proton to go in a circular path of radius 0.8 meters. What is the field strength? Well, what are the forces on the proton? The only force on the proton is from the magnetic field. So force equals the charge times its velocity crossed with the magnetic field. So this ends up being just QVB. Well, we know this is moving in a uniform circular motion, so we know that the force is also the centripetal force. The centripetal force is mass of the proton times velocity squared divided by the radius of curvature. All right? So we have our two basic pieces. I'm going to type these up for you real quick. So we know that force equals Q V cross B. Right? And that we're going to just write as force equals QVB. We also know from the centripetal acceleration that force equals mv squared over r right, which we're also going to just write as force is mv squared over r. Now we can take these two and set them equal to each other so that we've got QVB equals mv squared over r. And what does this give us? This gives us two of the v, the v's one of the v's cancels out. This gives us QB equals mv over r. Now what do we know from the problem? We know from the problem that v equals 7.5 times 10 to the 7th meters per second, 7th, 10 to the 7th meters per second, right? We know that the radius is 0.8 meters, right? And the mass of the proton, what is the mass of the proton? Mass of the proton is something like 1.6 times 10 to the minus 27th kilograms. No, 1 times 10 to the minus 12 times 10 minus 27 kilograms. I need to check that real quick. .67 times 10 to the minus 77. Okay, I was right with the 1.6. So 1.67 times 10 to the minus 27 kilograms. That just leaves us with, we know the charge, we know the velocity, we know the mass, we know the radius. So now we have the magnetic field strength is mv over qr. And we know q, right? Q of the proton is 1.6 times 10 to the minus 19 coulombs. All right? So now this is 1.67 10 to the minus 27 kilograms times the velocity was 7.5 times 10 to the 7th meters per second divided by the charge, 1.6 times 10 to the minus 19th coulombs, and the radius, which is 0.8 meters. All right? What does all this work out to be? Let's pull up Excel. And enter our numbers. So we've got 1.67 e minus 27. We've got 7.5 e7. Oh, 7.5 e7. We've got 1.6 e minus 19. And we've got 0.8. And the B field we're looking for is this times this divided by this divided by this. 9.79 times 10 to the minus 1. So we get in the end equals 0.979 Tesla. And there you have it.